Electronics comprises the physics, engineering, technology and applications that deal with the emission, flow and control of electrons in vacuum and matter. It uses active devices to control electron flow by amplification and rectification, which distinguishes it from classical electrical engineering, which uses passive effects such as resistance, capacitance and inductance to control current flow. Electronics has had a major effect on the development of modern society. The identification of the electron in 1897, along with the subsequent invention of the vacuum tube, which could amplify and rectify small electrical signals, inaugurated the field of electronics and the electron age. This distinction started around 1906 with the invention by Lee the Forest of the triode, which made electrical amplification of weak radio signals and audio signals possible with a non-mechanical device. Until 1950, this field was called radio technology, because its principal application was the design and theory of radio transmitters, receivers, and vacuum tubes. The term solid-state electronics emerged after the first working transistor was invented by William Shockley, Walter Hauser Brattain and John Bardeen at Bell Labs in 1947. The MOSFET was later invented by Mohammad Atallah and Davon Kang at Bell Labs in 1959. The MOSFET was the first truly compact transistor that could be miniaturized and mass-produced for a wide range of uses, revolutionizing the electronics industry, and playing a central role in the microelectronics revolution and digital revolution. The MOSFET has since become the basic element in most modern electronic equipment, and is the most widely used electronic device in the world. Electronics is widely used in information processing, telecommunication, and signal processing. The ability of electronic devices to act as switches makes digital information processing possible. Interconnection technologies such as circuit boards, electronics packaging technology, and other varied forms of communication infrastructure complete circuit functionality and transform the mixed electronic components into a regular working system, called an electronic system. Examples are computers or control systems. An electronic system may be a component of another engineered system or a standalone device. As of 2019, most electronic devices use semiconductor components to perform electron control. Commonly, electronic devices contain circuitry consisting of active semiconductors supplemented with passive elements. Such a circuit is described as an electronic circuit. Electronics deals with electrical circuits that involve active electrical components such as vacuum tubes, transistors, diodes, integrated circuits, optoelectronics, and sensors, associated passive electrical components, and interconnection technologies. The nonlinear behavior of active components and their ability to control electron flows makes amplification of weak signals possible. The study of semiconductor devices and related technology is considered a branch of solid-state aspects of electronics. Electronics has branches as follows. An electronic component is any physical entity in an electronic system used to affect the electrons or their associated fields in a manner consistent with the intended function of the electronic system. Components are generally intended to be connected together, usually by being soldered to a printed circuit board or passive. Vacuum tubes were among the earliest electronic components. They were almost solely responsible for the electronics revolution of the first half of the 20th century. They allowed for vastly more complicated systems and gave us radio, television, phonographs, radar, long-distance telephony and much more. They played a leading role in the field of microwave and high-power transmission as well as television receivers until the middle of the 1980s. Since that time, solid-state devices have all but completely taken over. Vacuum tubes are still used in some specialist applications such as high-power RF amplifiers, cathode ray tubes, specialist audio equipment, guitar amplifiers and some microwave devices. The first working point contact transistor was invented by John Bardeen and Walter Hauser Brattain at Bell Labs in 1947. In April 1955, the IBM 608 was the first IBM product to use transistor circuits without any vacuum tubes and is believed to be the first all-transistorized calculator to be manufactured for the commercial market. The 608 contained more than 3,000 germanium transistors. Thomas J. Watson Jr. ordered all future IBM products to use transistors in their design. From that time on, transistors were almost exclusively used for computer logic and peripherals. However, early junction transistors were relatively bulky devices that were difficult to manufacture on a mass production basis, which limited them to a number of specialized applications. The MOSFET was invented by Muhammad Atallah and Davon Khan.